Hello, this is Clayton with Aeromotive Research and Development Group. Today, we're going to have a coolant system performance presentation here for the SynMax University. We're going to be talking about horsepower, BTU heat energy, water quality, and so just strap yourself in because we're going to have a really good learning experience here today. One of the theories we have to look at is heat transfer because the cooler it runs, the longer it's going to last. You see, above 160 degrees, when you reduce operational temperature about 20 degrees or 10 degrees centigrade, the overall component life will increase greatly. Depending upon the specific composition rate, it will be better. Now, you've got a choice. You can use your standard tap water like most people do with a cheap treatment, and you can be running at the temperatures that you're running, right, 250 to 225 degrees, or you can make the choice with distilled water and a professional performance chemistry, all right, that will be able to improve on average, the overall average, about 10% of the cooling system efficiency. As long as you don't have a heat soak and you got the fluid flowing in airflow, your racing temperature will come down about 10%. Now, one of the things we have to look at is what's called horsepower in British thermal units, all right? And the more heat energy you have, the more heat that's generated, the more it has to be dispersed. Now, this works for your engine, your transmission, your drive axle. You see, the act is this: energy equals horsepower equals BTU energy. We're going to go over this for the next couple minutes, all right? The more energy you create through horsepower and torque, the more heat in BTUs need to be dispersed. Now, we've got a calculation factor down here on how you can be able to work that out. Again, the higher the horsepower, the higher the heat transfer requirement. Now, sometimes you're going to be limited on the size of the radiator or situation, so this is where a better chemistry to be able to transfer the heat is done. It's called a qualified heat rejection transfer process, which allows a cylinder, a chamber, walls, heads, and components to operate cooler with greater performance efficiency. You see, the cooler operations are necessary to reduce the rate of thermal metal fatigue, or embrittlement, or degradation of the piston, cylinder walls, cylinder heads, and components. Combustion chamber area has tremendous heat transfer requirements, as you know. You see, the cylinder area temperature must be lowered or cooled to prevent pre-ignition and detonation or dieseling effect. Now, modern fuel injectors is what's called a NOx sensor, all right, but a carburetor doesn't. All right, so this is why you have to be able to control this with the best efficiency possible. Now, the fact is, the higher the combustion chamber temperature, the higher the octane number to prevent pre-ignition and detonation. And so, if you qualify in the morning and then you got to race at 20 to 30 degrees difference. Here's the deal. The higher the combustion and inlet air temperatures, it reduces the humidity density. In other words, the amount of oxygen and water suspended in the air. This is important after 85 degrees Fahrenheit. It reduces the ability to cool the combustion chamber and performance quality of the fuel-air mixture. So, the answer is to improve the efficiency of the operation conditions with cooler temperatures best as you're able to do. Now, this is done by a qualified professional coolant chemistry with purified distilled water. Now, most of the heat transfer is in the coolant system by convection, and we're going to get into that. You see, heat convection, here's the definition: it's the transference of heat energy from a fluid by the actual movement or transference of the heat molecules from one place hot to the other cool. All right, so we've got the hot from the engine going to the radiator, and it cools off and it comes back, and then you've got a cool convection process, which is the transference of cool product molecules to the hot. I said, well, that's kind of basic. Well, it's very true. Now, the key is to have a clean situation from the start. Prevent the problems before it happens. We're going to get into that. It's by using distilled water with a professional formulation, all right, to properly conduct the duties of performance repeatability. Again, a considerable amount of available energy, heat, must be relieved from the metal in the combustion chamber through the heat transfer or convection process. All right. This is performed by the coolant system dispersing the heat into the atmosphere through the radiator, also called a heat exchanger. Why? Because it exchanges the heat. This is why the coolant system passages have to be clean and everything has to be designed to not allow additional system pressure, which the water cooler product does not do. Each material has its own heat density and thermal conductivity. Aluminum is the best. Now we're going to get into the question of pure water or distilled water versus tap. All right. And what we want to be able to use is distilled water. Now you can either use the technical grade, which comes with the water cooler premix, or you can buy it at the grocery store as we get along. You see, well, should I use a glycol in there? No. Distilled water has 3 times better thermal conductivity as compared to glycol coolants. All right. Now here's the other thing that we're going to get into is at 130 degrees, 130, 140 degrees, the salts and minerals will be released from the water from the tap water. All right. Distilled does not have that problem. See, the reasons for distilled water, again, is no matter the level of purification or filtration process, there is traces amounts of salts and minerals in the water. All right, it's going to conduct electricity. It's going to start eating into the metal. It's going to create multiple problems, including corrosion, rust, and contamination. Again, the reason for distilled water, all right, the purities are removed from the boiling of the water, condensing the steam, which leaves the salts and minerals behind. All right, you want something that doesn't have any of the contamination. The distilled water that also needs a qualified coolant additive package, which the water cooler provides. All right, distilled water alone does a really great job, but it needs the other additive package in there to be able to protect against the rust, corrosion, foam. Very important, the alloy gases that come from the aluminum. It will help prevent that and increase lubrication, conditioning, and heat transfer. You need an additive with the distilled water. Now, as we mentioned before, but the water looks clean and it tastes good. That might be true, but there is micron salts, minerals, and contaminants that's invisible to the eye that falls out at 140 degrees. As mentioned, distilled water through evaporation and condenses is 100% clean. Do not use local tapped or filtered water. Go to the supermarket and get some distilled water. Now, here's the results of using tap water or just average. It's really good water. It's not. Here is a radiator with the rust and the contamination which took place after 2,000 miles of racing. It is not a good thing. Now, you also want to be able to use a qualified product such as the water cooler system treatment. All right, and it does everything as mentioned here, improving the heat transfer performance, many protections, reduces the alloy gases, and protects aluminum and steel. So what you want to do is take the water cooler. You can use it with 3 gallons of distilled water for 5% FIA legal treat rate, which is an international accepted for general rules of competition. If you don't want to have to buy the distilled water, you can be able to buy the water cooler premix. This is a racing coolant product. All right, it's 100% technical grade. All the chemicals are in there. 100% premix, guarantee quality every time, and fulfills the 5% FIA international racing treat rate. Now you got a simple choice. You can either use distilled water with water cooler, which is on the left, or you can use tap water in a common radiator treatment, and you'll have the results on the right. Now, here was a radiator, 2015. It was a C&R double pass radiator, and it was used for over 2,000 miles. There was an accident at the championship race at the end of the year, so we were able to get it. And you can see the cleanliness of the coolant passages. This is after 1 year of racing. It is an amazing thing with a water cooler coolant product. Again, here was the C&R short radiator, a short track radiator. It was a Chevy steel block, all right, or it was a steel block engine with aluminum radiator and aluminum components, all right, 525 horsepower, 2,000 racing miles. This is the result of a qualified product, all right? Everything inside was 95% like new. If it wouldn't have gotten into an accident on the radiator, could have used that radiator for another year or two. Now, the IndyCar five-time national champions engine provider, they've been using this since 2011, 2012. All right, in 2015, this radiator was provided for the Dallara chassis by PWR. This radiator cost about $9,000 when it was purchased. And you can see how clean the system is and the pressure control that was provided. All right, the tanks, the tubes, the engine, everything was clean. Furthermore, when they would put additional engines in, they always knew it was clean and the radiator would be fine. Now, how do they do this with this engine manufacturer? Well, it's simple. From the engine build to all race operations, everything in between, under technical directive, it was Sinmax water cooler. This is what the entire picture of that IndyCar radiator looked like. Now you can see some of the rocks and hits that I went through, like 230 miles an hour. They had to replace it after 1 year because it was just an annual thing. All right. So this was 5,000 miles of racing, 700 horsepower, 12,000 RPMs. The radiator inside was still like new. So we're going to get into the treat rate. What is an acceptable treat rate under the general rules of competition for FIA, Le Mans, Formula One, IndyCar, SCCA, NASCAR, or any other sanctioning body? It's going to be 5%. You can be able to do that. Okay. And glycol is not an acceptable product to be used in the race engine because it's bad for the environment. Plus, it's hard for the track teams to be able to clean it up off the ground. So you do not use that. Most racing is going to be above 32 degrees anyway. And either run the system dry when you transport it or use the Aeromotive racing coolant, which we'll get into later. Then we look at the general rules of competition. All right, if everybody wants to see what's going on, so you got nothing special, just go to the local grocery store in the city where the racetrack is at. Go to Walmart. I don't care. Target. I don't care. There is no unfair advantage. Just go buy everybody where they can buy distilled water. Go right ahead. Do it. Be open book with them. Pour it in, and then they can be able to see that there's nothing special. Just like any other, you are allowed a coolant system radiator treatment to prevent rust and corrosion. All right. Does antifreeze and glycol mixture help in a coolant system heat transfer? The answer for that is no, it does not. Glycol antifreeze is not approved by any racing sanctioning body, which is like ethylene and propylene glycol. Again, if you were to use a glycol mixture, you'd have to have a radiator about twice the size of what you're doing right now. So the only way that you can improve efficiency is by having a better coolant system product. As mentioned before, the higher the horsepower, the higher the transfer needs. We have to remember energy requires heat transfer. All right. Here's another thing that's needed. We have to remember you have to have clean air flowing through the radiator, and you have to have, for the flow of heat to work properly, and qualified fluid to go through to work on everything, because you want to be able to increase the engine performance and component durability. So here we have the Sinmax water cooler concentrate. What we have here is a product that works with a 5% FIA treat rate. It will provide overall coolant system efficiency. It'll increase heat transfer, convection capability. It'll decrease the nucleate boil and film performance by controlling it. It will reduce foaming and cavitation. The alloy gases and system pressure, it will pretty much eliminate that. Cylinder head combustion chamber overall temperatures will be reduced. Contamination of the coolant passages will be reduced. It will protect the steel and the aluminum from rust and corrosion. Protection against electrolysis, pH balance, and acidic control. It'll help lubricate the water pump bearings, reduce the friction inside of the system, and condition the seals, rubber hoses, and components. Should you want an altogether product, a racing coolant product, consider the 100% premix. Everything is there as required. Since 2012, for the last 5 years, the water cooler product has been used by the Indy Car Manufacturer Championship for 2012, 13, 14, and 15 with the V6 700 horsepower program. The antifreeze which you use is a bio-based product within these Indy engines during winter testing. Aeromotive Coolant 7. Now, if you'd like to have a bio-based high-performance product, consider the Aeromotive Coolant 7. All right, it's able to go to 75 degrees below zero, 300 degrees above zero, and have the capability to control everything for a very long life, close to 50,000 hours of operation. Now, the Aeromotive Coolant program, although it was developed in racing with proven durability, is designed for military, marine, and commercial applications for gasoline or diesel, extreme duty, and long life applications. So we wanted to thank you for our time together. This is the end of our presentation for the horsepower and BTU energy water quality product. As Wayne Lensing says, a racing radiator, cleanliness, and performance will equal championship results. Should you desire to purchase the Sinmax water cooler products, please contact them at www.sinmaxoil.com. Give us a call in the Chicagoland area at 815-389-9999. So on behalf of Wayne Lensing, Danny Lensing, Performance Parts Supply, the Left-Hander Chassis Group, and Sinmax Performance Products, we want to thank you for the time that we spent together. Should you have any technical questions, please send us an email at office@aeromotiveresearch.com. Thank you, and we'll see you at the next presentation.